Good morning. In this video, we are going to discuss about diathermy. Diathermy is a form of physiotherapy. We are going to apply the physical stimulus to the human body in the form of heat. We are going to apply in the form of heat or a high frequency energy from the special generators. We are going to apply the high frequency energy to the deep lying tissues, for example, muscles, bones, internal organs, etc. The high frequency heat therapy is based on the dipole molecules of our body. Our body is having water molecules, that is, dipole molecules are there. We are going to give a electric field in that. Due to this field, the molecules will start to rotate. So, due to the rotation, the polarity of the molecules are changes. So the positive polarity will come to the negative side, the negative will come to the positive side. Because of the change of the polarities, the heat will be produced within the tissues itself. So electric field is going to be applied. Because of the electric field, the micro heating effect results in our molecules. So the disadvantages is sometimes it increases the temperature. Skin temperature will be increased, but here the heat is not penetrated properly into the body. For example, some other methods of heat therapy is hot compressors, infrared lamps, and also externally they are using hot towels, heat lamps, heating pads, and all they are using to provide the heat to the that is the required areas of tissues. And but what happen means, because of these methods, skin burns, and also the heat when we apply through the towel means it won't penetrate to the deeper layers. So that is the major demerit of the method. That's why we are going to apply the diathermy technique. So diathermy means through heating. We are producing the deep heating directly in the layers of the body. So it's nothing but it is we are making to have a electrical circuit in the body, and we are not going to transfer the heat energy. The heat energy will be produced within the tissues itself. And also diathermy is not only for heating, and also it can be used for cutting coagulations of tissues also. So this treatment will be very easy, and also easily the localized regions of the tissues can be reached by this method. And we can adjust the heat. Depends upon the need for the patients. The amount of heat what we are applying can be easily adjusted. And also the interlying tissues, muscles, bones, internal organs, everything can be provided with the heat energy. And the various types of diathermy are available: shortwave diathermy, microwave diathermy, ultrasonic diathermy, and surgical diathermy. So here we are going to discuss about shortwave diathermy. So here the frequency is 27.12 megahertz and the wavelength is 11 m. And here when we are applying this short wave to the human body, the motor and sensory nerves are not stimulated and there is no muscle contraction. It won't disturb the human anyway. And also mostly it won't have any no discomforts to the patients. We are going to apply the alternating current. So because we can reduce the intensity by applying this current, we can reduce the intensity. And also we are going to use oscillators to generate the waveforms. RF energy only we are going to use it, and the intensity of the current can be easily we can adjust it and regulated. And we are not going to use the electrodes directly in contact with the skin. So usually we are going to have some towels like that arrangement. Through that only we are going to apply the electrical current. See, this is the circuit diagram. So in this circuit diagram we can see we are having a transformer T1 and also we are having a oscillator. Here we are going to have a LC oscillator arrangement, and also we are having a triode also. So the primary of the transformer is connected to the mains, to 30 volts, and the secondary of the transformer is connected to this oscillator circuit. And here we are having that is we are having EHT, that is we are having EHT for the anode of the triode voltage. The triode is there, extra high tension voltage we are providing, and it produces the high frequency current. This high frequency current will be from this transformer is supplied to the oscillating circuit. So in the oscillator, you can see here two coils will be there. One is that is AB coil is there, EF coil is there, CD coils. So totally we can take it as a three coils. We can take it three coils. So first coil is AB coil. That is where that coil is mainly for patient's resonance. We are going to make a resonance using this AB coil, and the CD coil is mainly for the positive feedback. We are going to use it, and EF coil is also there, that will act as a variable condenser. You can see there EF coil is there. So we can have EF coil. So LC here only the circuit makes, and AB is for we are using another coil, and CD is one more coil. CD is for feedback and AB coupling purpose, and EF is variable condenser. So here the voltage is 4000 volts, and also here only one positive cycle, only the high frequency is generated, not for all the cycles. For positive and negative, only for the positive half cycle the heat is generated. And here this we can adjust the intensity of the current by adjusting the anode voltage. We can see four methods are there: by controlling the anode voltage, by controlling the plumb and heating current, by adjusting the grid bias, by change of grid leak resistance, and by adjusting the position of resonant coil with respect to the oscillator coils. So we can adjust the intensity of the current by doing the above things. The best way is adjusting the grid bias. That is the major thing. We can use the this method for adjusting the intensity of the current. And also here they are using a main filters, that is to suppress the inference produced by the diathermy unit. The diagrams we have seen this. So this is the circuit diagram. We are having a transformer and the oscillator. So the output of the circuit is applied to the patients through the electrodes. We are going to apply it. And also the electrode how we are going to use means two types of electrodes here we are using in short wave diathermy. One is capacitive method, another one is inductive method. The capacitor method is also called as condenser method. So usually directly we are not going to place the metal electrodes on the human body. So we are going to have some towel arrangement, layers of towels. So interposed between metal and the surface of the body. Using these towels, it will act like a pad. Using this only we are going to be place our metal electrodes. And here if you see here that we can come here, this you can see there. This is the way we are going to use the apply the electrodes. See there, this is the human knee. So they are having some joints. These joints need to be treated. So for that only we are going to apply the heat. So for we are going to apply the shortwave diathermy waves. So the waves can be applied. How we are going to produce the heat wave means by applying the current. The current will be applied to the electrodes. So again we are having some arrangements like the towels arrangement and all are there. Then we are placing the electrodes. So these electrodes will, the capacitor, you know about this, two parallel plate capacitor like that. So it will act as a two plates. Between this dielectric medium is there. So it will act as a capacitor like that. So this is the way the capacitive method of applying electrodes or condenser method of applying electrodes. So both the sides both the sides of the knee we are keeping the electrodes. We are applying the current. So the electric field will be created and the current will be, the internally heat will be produced. And another thing is method is inductive method of applying electrodes. So we can see here the leg is surrounded with the coils. So that is the difference. The inductive method we are using the coils as electrodes. The previous one we have used the metal plates. So we are going to apply the eddy current will be generated here. Here both the fields are there. Electric field is also there. Magnetic field is also there. So we are going to apply the current through this electrodes. The electrodes are nothing but coils. So you can see here we are having some, it can be used for the superficial layers. Here the heat will be generated in the superficial layers. This technique is also called as inductothermy, and here we are going to set up two fields. As I told, two fields. One is electrostatic field, another one is the magnetic field. The electrostatic field is around this corners. The center we are going to have the magnetic field. So this is the way we are going to generate it. The flexible cable is as a coil that is surrounded in the arm or knee. So easily we can surround the areas where we have to be treated. Here also we are going to use the RF current. Sometimes we can't apply the continuous RF waves. This may cause us some irritation, some skin burn, like that, and all. It may create some problems. So wattage we have to lower it. For that, what we can do means, instead of going the continuous RF waves, we can go for the RF pulses. So this method is called as the dia-pulse shortwave diathermy. So here the pulses is for the duration of 65 microsecond, and the interval between is 1600 microseconds, and the 38 watt we are going to apply it. So in this video we discussed about what is diathermy, what are the types of diathermy. So the first method of diathermy, shortwave diathermy, we discussed. Using shortwave diathermy, the waveforms are produced using transformer and oscillator circuit. We are going to use the LC oscillators we have used here. The waveform generated is a short wave that will be applied to the human body through electrodes. The electrodes are placed around the knee or legs, like that we can place it. That will act as a capacitive method. Two plates will be used. In the inductor method, coil is used. Thank you.